Hello everyone, and welcome to our next video. So to briefly summarize what we did in the previous two videos, we focused on writing a bunch of user stories that focused on our authentication functionality. So if I come to my backlog here, you can see that I have a couple of user stories that focus around sign up, or the focus on sign up, on verifying sign up information, sign in, and sign out. So it's a very basic setup for the authentication. Of course, it's not going to be our whole authentication process. We will actually implement OAuth and OpenID Connect, which I think is something that will bring a lot of challenges to our implementation, or it will require a more complex setup than to just make an email password store in the database flow. So I want to present this because I think also many companies use this as an industry standard. So it's very nice. It is very profitable for us in terms of knowledge if we can discuss this. So we also wrote down a couple of subtasks, and we created our first Kanban board, which we will start implementing in the next video. And why not in this video? Because I want to give some background before we actually go into implementation. So our goal is to implement the sign-up functionality both in the backend and in the front end. We'll start with the one for the backend. So that's the first user story that we have. And then we will, after implementing the one for the backend, we will focus on the front end. So we still need to set up the front end, and then we can start working on implementing the functionalities. But before we move into implementation or into actually coding, remember that in the first video of this series, I mentioned test-driven development, right? And some people like test-driven development. 99% of people don't do test-driven development, and that's a pity, right? Of course, I understand there are limitations to test-driven development, but in a world where our focus is to implement microservices, test-driven development, it plays a crucial role. So one of the goals of microservice is to increase velocity. We want to deploy software more often, and we want to deploy software with more confidence. That means that, well, if I have a monolith, it takes a while until I deploy a new version, if the monolith is big, right? If the monolith is just a couple of files, then it doesn't take that much time. But if the monolith is a complex application, I need to make sure that my changes don't break other dependencies. I need to make sure that my adjustments are not breaking my application somewhere else. And in this sense, testing in a monolith is of course more complex than testing in an isolated context of a microservice. And why do I say isolated context? It's because microservices by nature, they tend, or they focus on being loosely coupled from other microservices. So this doesn't mean that microservices don't interact between each other. It means that they interact through a well-defined interface, so a message exchange, right? What we would call an event broker or an event bus, whatever you want to call it. We will come to this implementation at some point in the future. I cannot foresee how many dozens of videos we go through before we actually get to the implementation of asynchronous messaging in microservices. But the idea is that in a microservice, I am able to deploy that microservice without worrying, or I should be able to deploy that microservice without worrying whether the changes in that microservice are going to break another microservice. Of course, I need to ensure that, for example, if I change the interface of the messages published by this microservice, then the other microservices need to be aware of that. But this is a process that is not really encouraged. In fact, I personally think that the interface for message exchange in a microservice world should be very well defined and should be standardized across microservices, so that I don't have this problem, or at least I minimize having this problem of inconsistencies in messages, right? And of course, I also need to have, from the receiving end of the microservice, I need to have some implementation of some logic to deal with messages that are not following the exactly expected format, because let's say that I deploy changes in one microservice at minute 1, and then I am able to update the other microservice that receives these messages only in minute 2, but there is a whole minute that can be hundreds, thousands of messages issued or published by the first microservice that are not going to be correctly processed by the receiving microservice. So there are limitations to this whole idea of testing in isolation and deploying in isolation. So loosely coupled is not entirely decoupled, right? It means like loosely coupled. But I need to have confidence that my microservice is executing the functionality that I want it to execute. So if I start writing the code and then I write the tests, it means nothing. It means absolutely nothing, because I already know what the code does. So the test helps me only to confirm that the code is behaving how my head expects it to behave, and it points out if there is a flaw in implementation, but it does not point out if there is a missing business requirement within that code, or if there is a somehow misunderstood implementation, because I look at the logic of the code and I write the test. Okay, for this if statement, that output should be produced. For this while statement, that output should be produced. And this is derived from the code that was already written, but there was nothing to begin with that defined what that code should exactly do. And this is where writing tests first can actually help us. So we can focus on writing business requirements first, so that I know exactly what my functions should do in my code and everything that my functions should do in my code. And then I write the code so that those business requirements are implemented. Nothing more, nothing less. And this is the principle of test-driven development. So I put together a, of course, very simple, because there's not much to this science. I mean, there is a lot behind the theory of how do I ensure that my code is well tested, and coverage is not enough, right? And coverage of what? Is it of lines? Is it of statements? Is it of branches? So coverage doesn't tell me everything, but test-driven development helps me confirm that the business requirements are working correctly. So to begin with, we write a test, right? So we are going to write a simple test, and of course, the first time we run this test, it's going to fail because I don't have any code, right? I just have the test, and if I expect, it's not even going to compile, because the function that is expected to run within the test or to be tested is not implemented, so test fails. Then I write the code so that the test is going to pass, and then the test passes. Of course, the test can still fail if the code is buggy, but I know that I should not change the test. I should change the code, right? So the test passes, and then I go and I move to writing my next test. And this repeats itself. It's a very iterative process. It's a very dynamic process. So another thing that tests allow us to do is that, well, I think we'll get to this. I have a couple of slides to discuss the benefits of test-driven development. So I was watching a talk, so a video by Uncle Bob, right? If you know Robert C. Martin, So he's a big name, and if you haven't heard of him or read his books or watched his videos, I would recommend. So he presents in this video here at the bottom 3 laws of test-driven development. So the first one, and they are increasingly more strict in scope, right? So the first one, I'm quoting him here: you are not allowed to write any production code unless it is to make a failing unit test pass, right? So you cannot write anything as long as you don't have, as long as you don't have a unit test that is failing. If all the tests are passing, then you don't go to production code, you go to writing new tests that will by definition start to fail, and then you write the production code to make those tests pass. So you go get a little bit more strict in scope, and then you say, okay, I'm not allowed to write anything else in a unit test, then it is sufficient to make that test fail, right? And compilation failures are also failures. So if my test is passing and I wrote one more line and my test started to fail, I should stop writing the test and go to production code and make sure that that test is now passing, right? And this is the third rule. So once my unit test is failing, then I should stop writing the test and go to the production code. Now, of course, it's a little bit maybe too strict, and we are talking about a guy who has dozens of years of experience with programming and was there virtually at the beginning or close to the beginning of things. So we cannot expect that we will be able to implement the rules or the process as well as he suggests, right? So of course there will be some restrictions, or there will be some flaws maybe in our implementation. We are not going to get it right for the first time. We will try our best and we will improve as time passes, but for sure there is a learning curve to test-driven development. But we need to do it. And why are we going to implement test-driven development? Well, there are a couple of reasons, right? He also points in his video. So the code documentation is done through unit tests. If we write the tests and we comment the functions with doc strings, right? So in Python it's doc strings, but so the idea is just to write a documentation header to the function so that it explains briefly what the function does, the inputs it takes, and the output it provides, or what it returns, right? So it takes the parameters and it returns some value or returns null. And basically it's if you work with Java, then you know all the little comment blocks that are on the top of each function or on the top of each method, on the top of each class, that explain what that method or that class do, and which kind of inputs and or parameters and which kind of return it provides. So this is one way of documenting, but tests also provide a way of documenting because they explicitly tell you what function X produces and which kind of parameters it takes. And if the test passes, then it's not a string telling you what it is, what the function is supposed to do. It is a proof that that function works correctly, right? So this one thing. Next thing is that the code and the function design are then driven by the tests. They are not driven by my head, but their entire focus is to make the tests pass. And another thing is that, well, imagine that all my tests are passing, and then suddenly the test I'm writing, it stops to work, right? It's not passing anymore. So I don't really have a lot to think about, because it was a very small change that I did that started failing the test. So I know exactly what I need to redo or what I need to undo, or where exactly in the code the problem is supposed to be. So when I have the tests first, I have a much clearer idea of how I can debug and analyze my code. And It was very interesting. In the video, he mentioned about not being a fan of debuggers, and I finally got some confirmation to what I already expected to be the case for many months, that yes, debuggers should not be used as much as we use them. So we need debuggers if there are a lot of bugs and complex bugs, right? If the code is straightforward, if we know what we are implementing, and if we know what we want to achieve, and if we do that incrementally with small and isolated tests, then this definitely gives us a much more straightforward structure to the code so that it's much easier to analyze it. Oops. Yeah, and it also, and that's perhaps the most important aspect for us, we need to ensure that our system behaves as expected before we deploy it to production. Right? We cannot manually test everything again. We need to have tests to ensure that the previous functionality of the system is working, even though maybe I implemented a few changes in function X, Y, and Z. And tests also help us with refactoring, because if I start my refactoring and at the middle of my refactoring my test breaks, I did something wrong with the refactoring, right? The function was working. I decide to change something in my function and suddenly my test stops to work. So I did something wrong. Maybe I put a wrong parenthesis, or maybe I forgot a variable. Maybe I declared something as a different type or whatever. Then I can easily identify that, okay, it's not a flaw in the logic because the logic is correct. It's a flaw in my refactoring. So back a little bit to microservices. If we want to implement continuous delivery, if we want to create a flow that every time a pull request is merged into master, that new change is automatically deployed to production, I need to have confidence on my system. I need to know that my system is still working as expected. I cannot guesswork here because, okay, we can, because we are in a somehow non-binding scenario, right? But if you were working for a bank, if you were working for a financial institution, if you were working for a health insurance, if you are working for any company for that matter, if you change something and that something breaks some other part of your code and you don't know about it, and this happens very often, then all the hell breaks loose, because you need to go and quickly fix the bug, quickly debug this to production, deploy this to production, so that you hurt as few customers as possible. Right? So tests give us confidence only if we write them first. If we write the code first and then tests to make that code pass, or like tests overfit to the code, then they don't tell us anything, right? But if we write the tests first and then the code, then they give us a lot of information about our system. Okay, yeah, sounds like the silver bullet, but of course it's not. There are many limitations to test-driven development, and these limitations, they don't come from the process of test-driven development, they come from the limitations from tests themselves, right? So the first thing is that tests cannot ensure the full correctness of the system. They can only point what is not working properly. All right, so if all my tests pass, I still cannot ensure that my system works 100%. And why is it? It's because I can have, or I will have, interactions between my system and external systems at any level. It's going to be my microservice talking to my event bus, for example, or it's going to be someone querying data from my microservice, or it's going to be some internal communication between different components of my microservice. There will be some external communication, some exchange of information going on between two different components of my application. And This can lead to some unpredictable or to some very hard to foresee combination of inputs that perhaps or most likely we will miss in the implementation. So we cannot ensure that everything works correctly if all the tests pass. We can only know that something is not working correctly because a test fails, right? So this brings me to the second point, is about unit tests being the most basic level of testing. And of course, if I test a function in isolation, I am not testing how my system integrates with other systems, nor I am testing how some action from the user goes through my entire system and produces some final outcome, right? So this integration between two systems would be considered an integration test. And this end-to-end behavior, right, from the very beginning until the very end, that would be an end-to-end test. So suppose we'll develop the backend in a bit, and I'm interested in testing the entire behavior of my route, of my sign-up route, since the beginning when it receives the request until the end when it returns the response to my user. So this would be, I think, would be a fairly fair to say this is a very simple end-to-end test, right? We will start writing this kind of tests as well, but it's not possible to do it for everything. So it may be the case that it's a very complex workflow and we have a lot of dependencies, we have a lot of unpredictable things that can happen in between. So it's not possible for us to always write end-to-end tests. We should aim for it, but this is a limitation of testing, right? Another thing is that we also have what's called acceptance tests. So acceptance tests is something that is done from a business perspective, and it is actually somehow an abstraction of an end-to-end test, right? So an acceptance test would be defined as what the system needs to perform so that it passes my acceptance criteria, right? So what are the acceptance criteria for that system? Maybe for the sign up would be, okay, acceptance criteria is when the user provides a valid email and a valid password, it signs the user up and it sends the verification email. And when the user provides invalid input, it returns an error to the user. So then we have a few acceptance tests. So the first acceptance test would be, okay, provide me with a valid email and password, then provide me with a valid email and invalid password, then invalid email and valid password, and an invalid, right? So that is one possibility. I think if maybe we go in the future a little bit more into the theory of testing, we don't need to test every single combination of inputs, right? So there are some processes for deriving a set of inputs that is going to be very representative of all the possible combinations, but it is much smaller. The set is much smaller so that we don't spend that much time running the tests. Okay. And the last problem is that these tests must be maintained throughout the project, which is really not a problem, right? I mean, I have to maintain code. So I should, of course, have to maintain tests, right? If the tests translate my business requirements, then the tests are even more important than my code, because my code is only supporting my tests. My tests are telling the user, or my tests are telling let's say the program what it should do, and then the program is going there and it's doing it. And if someone else enters the project, then that person looks at the tests and they're like, oh, okay, that's what the program is supposed to do. That's what the program is supposed to do. That's what this function is supposed to do. So of course I have to maintain tests, right? If a requirement changes, the first thing that it should trigger is an update on the respective tests, because now the business requirements, which are in our scenario here equivalent to my tests, they change, so the tests should change. So you see, maybe some people who are against test-driven development would complain that we have to maintain tests, but maintaining something is not the problem. The problem is maintaining something that is useless, right? So if my tests are useless and without any kind of value because they were written after the whole functionality was implemented, then of course it's a pain to maintain them. But if my tests are in the front of the development, they are dictating the development, then it's not only required, it's actually a pleasure to maintain the tests because they will always be updated with the latest business requirements. And because they are passing, because we did the necessary changes to the program, because they are passing, then I can ensure that my entire system, or at least ensure that my entire system is working, is exactly what the point one is saying. It's not possible, but to a good extent, I can ensure that those tests and those functionalities are passing in my system. Okay, so this was a discussion more type of video. No coding today, or at least not in this video, but it was to give you a very general idea, but also comprehensive enough so that you understand why I have chosen test-driven development for this project. And I have to say, of course, I'm not as good as people who are doing this for years, but I'll try my best. I'll try my best to stick to this pattern and to learn as much as I can as well, so that whenever I come across important, relevant knowledge, I can also share with you. Okay, that much for discussions. In the next video, we'll start writing our first test and our first functionality to the sign-up route on our backend. Thank you and see you then. Bye-bye.